Hey guys, today I just want to talk a little bit about cyclohexane and show you how to draw it. Typically, you'll see cyclohexane in organic chem class, usually in the beginning of the class, and that's because cyclohexane is just an alkane. It doesn't really undergo many reactions other than maybe free radical halogenation. That's basically all you'll cover in a regular organic chem class of reactions pertaining to cyclohexane. But what they'll really want from you as a student is that you be able to predict the more stable conformation of a cyclohexane when it has substituents on it. But what I want to do first is basically show you how to draw them. They're relatively easy, nothing too hard, nothing too out of this world. The more traditional way, I mean, depending on what your teacher wants, if they want you to draw it a specific way, then obviously you have to follow what they say, but the traditional way of doing it is as follows. You make two parallel lines, draw like a dot to the right, connect your two lines. Well, that didn't connect, but connect them, then draw another dot going down, connect the two lines. And I know that looks kind of funky, but that's typically how people draw them. The way I like to draw them though, and I find this pretty easy, helped me get through my old chem class, I just draw two parallel lines that are slanted, like so. Then I take a line from here, take it past the middle, like that, and then connect it going up to that one. And then we're going to do basically the same thing but kind of flipped. I take this line up there, make a longer line going down, and that's how you make it. And that's really a quick way of making it. I guess the more you practice with any way, you'll get faster at it, but you definitely want to practice these every day to really get it down, because when you're drawing these, you don't want to waste time on a test just drawing them. So you draw it like that, or however you want to do it, and then you got to make the hydrogens come off of it. So how I do it, I start from the left, top left, and I make my axial hydrogen first, and axial is just going up or going straight down. So I make all my axials first. So with cyclohexane, when you have this one, it's axial going up. So what will the next one be? It's just axial going down. And you continually go on up, down, up, down, up, down. So right here I have axial up. On this next one I'll have axial down. Then I'll have axial up, axial down, axial up, axial down. And then you have to draw your equatorial hydrogens, and that's basically the same concept, but it's going to be different from whatever you have already. Like, for example, this one has an axial up hydrogen, so it's going to have an equatorial down hydrogen, like so. And on this one, it has an axial down hydrogen, so it's going to have an equatorial up hydrogen. And you keep on going. So up axial, down equatorial, down axial, up equatorial, and up axial, down equatorial, down axial, up equatorial. So you can see that if it's going up axial, it has a down equatorial, down axial, up equatorial. And that's basically it. That's how you draw it. And so in going on, you're gonna have to do a ring flip, and that's simple. You just basically like it says, flip the ring. So you notice how in the first one I drew my first two lines like that. Well, on the ring flip, I just draw them like that and connect them the same way. Like this, go there, And I make the same axial and equatorial hydrogens as well. And as you see, it's the hydrogens are the same. It just looks like it's flipped, and that's all it is for the ring flip. Sorry, it got kind of crooked over there, but I think you get the point. It's not very hard. In the next video, we'll go into seeing how the ring flip changes the substituents on a cyclohexane.